All right. Well, hey,
Yeah.
everybody. Welcome. So glad you could join us today for this podcast episode. I'm super pumped to be joined by my good friend, Dennis Oleksyuk. Dennis and I met back in the day when we were working at DataRobot together, and we built some cool stuff, and maybe we'll get into that in the podcast. But I'm Greg Michaelson. I'm the co-founder and chief product officer at Zerv. And Dennis, why don't you introduce yourself a little bit?
Yeah, my name is Dennis Oleksyuk. I'm a co-founder and CTO of AirCon. This is a company that develops AI agents for air freight industry.
I definitely want to talk more about that. But before we do, give us a fun fact about yourself.
Oh my God. I don't know.
The funner the
Fun
better.
fact.
Come on.
Yeah, all my life is just a sequence of fun stuff that I do. I don't know. Caught me off guard.
You you should tell him about growing up on the coldest place on earth.
Yeah, so I was born in Soviet Union, and my parents at the time lived in Arctic because that was a cool place to go work and make money. Just like people right now going to Alaska, to all feels pretty much the same story. But somehow they decided to make a child and raise me there. So I grew up in officially one of the coldest places on earth, where like there is permanent settlements with humans and kids and everything. There are of course colder places in Arctic, but no kids are allowed. I grew up in a place where kids allowed, and it would routinely go below minus 50 outside. And that was the cutoff where we would not go to daycare. Before minus 50, we would walk a mile outside to a daycare. So
That's hilarious. The Russian people are a hard people. when
yeah,
I
I'm not
first
Russian,
joined
I'm Ukrainian.
DataRobot, oh yeah, when I first
Anyway,
joined
we're not going to
DataRobot
go there.
on my
Yeah.
on my first day in the office, I walked in, and our head of HR was Russian, and she was sitting at her desk, and she's sitting there going like this. And I said, "Hey, what you doing? Is everything okay?" She says, "I'm practicing my American smile."
My kids, they're Americans. They born in America, grew up in America, and they come up
Mhm.
with a new term. It's like, Dad, when you're focused and looking at the screen, you have a resting murderer face.
Yeah, that's what I'm like when I drive. I get the same comment. People will be like, "Why are you mad?"
Just focus. I'm trying not to
And the
die.
reason, of course, the reason, of course, is that people are idiots. So
Yeah.
anyway, all right. So we're going to talk a bit about agentic coding, the large language models, AI, production, engineering, data science. We can just kind of go wherever we want, because I'm really curious about your journey and how you sort of got where you are, and how did you decide to be an engineer, and give us like the 50,000-foot view of how you arrived as the co-founder and CTO of a very
Oh
cool
my God.
startup in a very weird space.
It's a result of very random walk. I never wanted to be a software engineer as a kid. I love computer. I love playing games. I love surfing internet, doing all of that. My parents saw that I was, mathematically and technology inclined, and they spent a big fraction of their income buying me a computer and giving me access to it. So I loved it, but I never thought about, doing a career I always looked at the computer as a tool, to do something else. But I was good at math and physics and all of it, and I was interested in the computers. And my relatives, friends of relatives, somehow convinced me that I should go and get a degree in applied math and computer science, and that's where I went. It turned out to be more applied math than computer science because it was old Soviet style university that before Soviet Union collapse was focused on developing stuff for military, nuclear submarines, nukes, guidance system, all of that jazz. So they knew their math, they knew their geometry, other things, but not computer science. But while there, I met other folks who were into the tech and who were actually hackers who, dreamed about doing it from the childhood. Caught a bug from them and start doing it myself. founded a small business with a couple of friends, worked in a million places, eventually end up in United States, working for big enterprise, and no AI whatsoever, just telecom software for big telecom companies out there. And then I just got bored out of my mind, and started reading and going to meetups, and while I was living in Boston, and went to one of the meetups and met a guy who was a VP of engineering at early stage startup. And we started talking, and I was like, yeah, I work in enterprise on this telecom software. I have background in math, so I can understand what you do with all this ML. At the time, it was machine learning. Even term of data science was not around.
Yeah, you have to rename it every 5 years so
you
that it
have
stays
to
cool.
rename. Yeah, that was time of machine learning, like not AI, not AGI, not data science, was ML. And they were doing some cool novel machine learning algorithm. And I was asking him, like, so being just naive off the board immigrant, I was like, how do I get involved? And he is like, you know what, send me your resume. Let's talk. And I sent him my resume. They invited me for an interview. And it was a fun interview because I'm good at math and stuff, but I'm not as good as the guys who were interviewing me. So they give me some problems to solve, like in optimization and related to machine learning, which I had no idea. I never studied that branch of mathematics. So I keep asking questions to clarify and try to make efforts. Never finished the big problem. Like spend 5 hours in front of the board. Was absolutely convinced that I failed it. Went home, wrote down everything I could remember they asked me with intention to go learn it. Be a proper engineer. And next day I got a job offer. So I called them up. I'm like, you guys probably screwed up. You sent one person. They're like, no, you're the only guy who didn't give up and kept going. Like,
The only guy who didn't give up. That could be the title of your memoir.
Yeah, that's the
The
title.
only
They're
guy
like,
that didn't give up.
yeah, it's like we have enough math guys from Cornell, MIT, etc., who can write algorithm. We need to put this stuff in production, make it work in real world, and we need real software engineers. Thanks God they thought I'm a real software engineer, and who can understand the math we do. And most people we interview just give up too fast. And you went deep enough that we're sure you can figure it out. So that's how I joined the ML AI world, and that startup eventually got acquired by DataRobot. So joined that revolution. But my path, yeah, my path,
Revolution. That's a funny word for it.
yeah, that's I don't know, civil war, whatever you call it.
That might be more accurate.
Yeah, but my past in AI was through my engineering experience, through my experience of building software and building highly reliable systems. So in DataRobot, I eventually found my path in helping to put machine learning models in production. Work with you on trying to build prototypes or proof of concept of solutions that use machine learning, and then just end up leading the team that develop all the infrastructure for all DataRobot customers to be able to take the model that they trained and put it in production. And through that, I got exposed a lot. Yeah.
The funnest thing we built was that pitch predictor.
It predicted the best. Like it's yeah. I don't know if you want to tell more about that.
And well, we realized that the Major League Baseball had API that would give you real-time stats on ball games that were going on.
Yep.
And so we built Dennis built an app that would go and predict what kind of pitch the pitcher was going to throw live during a game, which was awesome. Of course, then we got shut down because of like data licensing issues and stuff like that. But it was still fun.
The side effect of what we did was MLB forbids to wear smartwatches now.
Really? No kidding. Like during the games, the players can't
during
wear
the
them?
games. Yeah, during the games, they cannot have smartwatches because I think either it got to somebody or somebody replicated what we done and people start using it. The batters start using it because if the batter knows which pitch is coming, it's a huge percentage success growth. So So that's why I heard someone told me at some point that MLB's it, and I was like, you know what, it's probably my fault, you know, and,
Yeah, we
and your
did
fault.
talk to him and try and get him to
Yeah,
use
yeah.
get him to let us use the data, but they weren't
Maybe
having
that
it.
was the
So,
result. They went and like, you need to ban all the devices because people are gonna figure it out.
well, I'm surprised that it wasn't so much in gameplay as in like prop betting.
Yeah,
That big old, what was that big, was it basketball where there was the big scandal about players making prop bets and betting against like
I don't know.
their own stats or something?
I
You didn't hear
know.
about that?
I got way too much schooling in statistics to do any betting things.
Oh yeah, no, no, no. I don't participate. I just think
They
it's
beat
fun.
out of me all of that, so I don't even look at it. I don't even know how it works. Yeah, yeah.
Awesome. Now you're also an amateur biochemist, yeah?
I did some. I again get really bored at some point with the
Slash
corporate world.
slash slash baker.
Baker, yes, I get really bored with corporate world, and while living in New York City, New Jersey, by New York City, I stumbled on a lady who was used to be a head of like lab at the big pharmaceutical companies, and then got cut off, but had some like large severance package, so she couldn't work anywhere. So when she was too bored of her mind and ridiculously good by molecular biologist. So she started these courses for people like me who just want to learn about what is actually going on in real molecular biology, real, pharmaceutical field, not something you read from textbooks. And I got hooked on it, and then attended her. Like, she built a small lab, found someone who donated her workspace in Brooklyn, and did bunch of stuff there. Learn how to do a lot of techniques, molecular biology techniques, how to work in a lab. Like, till this day, I can walk in a real lab in like Harvard and pretend I work there, and they will not be able to distinguish me from their postdocs. Like, I can probably teach a lot of them how to hold pipetter correctly and to do a lot of things. Yeah, but that's it's just my brain is like that. I need to constantly learn something new. I need to understand the world. Like, I'm always curious about how things work, and at the time, the understanding how the body works, how the biology works, was like bizarrely interested. I'm still interested, but these days AI is way more occupies way more space in my brain. Like, it's so much information every day. I just don't have any brain cells left to follow and do anything in that
Yeah.
molecular biology field. Yeah.
Yeah, that sounds right. Do you find one of the things that I've been thinking for a while is that people are losing the ability or the will or the desire to like learn the nuts and bolts of stuff. And like, you hear all the time about, how AI is going to destroy the world and stuff like that. I think it's doing it from like the inside out, like the inside of people out, because you don't have to know anything anymore. You can just ask for it.
So I don't know. I mean, I cannot generalize for other people, but for myself, I found that I'm going even more hardcore now with AI, because before AI, if I wanted to look into something, I would Google something, start reading, and then I realized that I'm reading some technical book that was written for people who took another 5 classes in the same subject, and I cannot understand half of the words in it, so I just accept the fact that I never understand this particular topic. Where now with AI, I can just torture it with recursive questions. It's like I can go and say, like, explain me this, explain me this, explain me this, explain me this, and now roll up, re-explain me everything, and I can just go hardcore, because it gives you instant access to the information. So where in the past, yeah, you can Google it up, but if you look at any technical terms, like, I don't know, recently on the weekend, I went on a rabbit hole trying to understand how the modern GPUs are built and how they package in the servers, and how how they parallelize all of this, because one GPU cannot handle the entire model. I could go as deep as I want, with the LLM. Like, I just keep asking, and it keeps Googling stuff and keep bringing me up, and, summarizing, abstracting, etc. So I find myself reading way more, learning way more, understanding way more stuff than I did before LLMs were out. Yeah.
Hmm. Hmm. Now, AirCon AI, tell us a bit about like what you guys do, and I'm particularly interested in how you're using agentic coding and AI in your in your business?
Yeah.
If you can talk about it.
Yeah, I can talk, absolutely. I mean, maybe
Yeah,
somebody's going to
nice.
buy our product from this podcast somehow. Yeah. So to understand what we do, you need to understand a bit of the industry. There is a freight industry that's invisible behind everything. But anything that manufactures is being manufactured anywhere in the world, or any kind of company that does any kind of service ships freight. Because it's just way too expensive to ship stuff by UPS or FedEx. Once you get beyond particular size, what do? You end up putting stuff on a pallet and then shipping it by as a freight. And when you ship stuff by freight, it's a little bit more involved because the human cannot pick up the pallet. So that pallet is on warehouse, and the truck has to come to the warehouse, and the forklift has to put it on the truck, and then it goes to the next warehouse, and it's you're stitching together this path of shipment being forwarded from one location to another. And then if you go international, somebody needs to drive it to the airline warehouse. The airline needs to put it on a bigger pallet, put it on a plane, unload, unpack it, put it. So there is this chain of like 12, 14, 15 stops for the shipment from point to point. And to make it cheaper, it's not being handled by single providers like UPS, FedEx, etc. Each chain is handled by a specialized business that specializes at that particular step. For example, wherever you are, in whatever area of the United States you are, there are local pickup and delivery trucking companies. And all they do is they get a bunch of orders to go pick up pallet there, pallet here, drop off pallet in some place. So they just drive around like Uber Eats with pallets, and that's all they do all day long. And then there are companies who are specializing at line hauling it from a CDA to CDB. It's like a bus going back and forth, like the connection line, and on and on and on. So as a business that wants to ship freight, you just don't want to deal with all of these steps and stitch it all together. So there's the whole class of companies that arose decades ago called freight forwarders. That literally specialize in forwarding your freight. They stitch in together these routes, and either for ocean or purely for trucking or for air freight, and they find the right subcontractors, and they quote, book with them, track, they take care of all the paperwork if you're going international, etc. So it's invisible business, but it's to most people because it's 2 layers removed. Like you have manufacturing, you have logistic, and these guys are under logistic, but it's a huge part of logistics. Non-trivial amount of money that you pay for everything you buy is actually paid to these freight forwarder guys who coordinate the logistic chains globally.
Gotcha.
And logistic chains are very medium specific. There are people who specialize in trains. There are people who specialize in ocean. There are people who specialize in air freight, because just each mode of transportation brings its unique things. Like air freight, the biggest thing unique about it that freight flies on passenger aircrafts. Most air freight flies on passenger aircrafts. Air freight.
No kidding.
Freight planes are used if stuff cannot go in passenger aircrafts because it's too big or too dangerous, or you just have too much stuff you want to ship at once. Like when Apple ships their iPhones, they usually time it to go exactly in the United States particular time, so they ship everything at once. Then they take freight airplanes because they just need so much capacity. But other than that, majority of it flies on passenger aircrafts, which puts a lot of restrictions and a lot of procedures, because just like you go through TSA with your stuff, the freight that goes on a passenger aircraft, all the way from manufacturer to the plane, has to go through custody chain. Like the people who touch it have to have particular certification, follow particular procedures, etc. So the freight forwarder who specializes in air freight needs to know all of that, so they don't go to jail, or they don't cause trouble for the shipper to go to jail or get fees or get in trouble with TSA. So that's the industry, and I had to describe it because otherwise what we do would make no sense. So what we do AI agent that help to perform that work. Like it's, when I say help, it performs some of those roles completely independently. For example, right now we have a coding agent in production that whenever the freight forwarder gets email, the coding agent reads the email, extracts all the information that is needed, builds the routes for that origin, destination, shipment size, whatever properties are, finds the airlines that can fit it, trucking companies that can serve it, etc. Builds the route, adds the margins, forms the nice quote, and sends it back to the customer. And which actually for a freight forwarder is more than half of their time spent on these quotes, because once you have a quote, actually stitching it together, you already did the most of the work, pre-planning and pre-configuring the route. If somebody comes back and say book it, you just send emails to those guys or go to their websites and said, I need to book trucking, I need to book this, I need to book that. So. But the second agent we're doing is the booking agent, is the agent that's going to do that work, go book everything once the quote is built and customer
So
approved it.
your agent is requesting quotes from all these different people along the way?
Yep.
Wow.
I mean,
by email or through their website, or does it have to
no,
figure out why? Or?
mostly through API. We're trying to stay away from emails. We're gonna probably end up doing it because it's just no way out of it. But we're trying to stay away from emails because it's way too slow. And the reason why it's way too slow because of is international shipments, and half of your path is abroad, and because of time difference, if the quote came after noon, it's already evening there, so nobody gonna reply until morning time. So you're gonna get a natural 12-hour delay or 16-hour delay just from that. So we're trying to avoid using emails, but there are shipments that cannot avoid using emails because the API is not flexible enough. You need humans to make decisions. So, but for now, we
Is
just
it a
decided.
different API for every? Is it different API for every vendor?
Yeah, it's API
So you're
zoo.
just saying like you're like my package is 4 feet by 3 feet by 2 feet and weighs 600 pounds kind of thing, and they send you a quote.
Yes, pretty much. But you need to know who you can send this quote or not, because a lot of them will happily quote stuff they cannot handle. Like a great example are airlines, because it flies in the bellies of a passenger aircraft. Different size passenger aircrafts have different size of the door for the freight. Therefore, if the freight that cannot fit in the particular aircraft or particular airline that connects to cities, you cannot tender it to that airline. But airlines will happily give you a quote for that origin destination. So because their quotes are usually kilo based, like, hey, here's how much per kilo, and go and knock yourself out.
Gotcha.
So you have to have more intelligence, more domain knowledge about, hey, we need to consider what airplanes this airline are flying between these 2 points. If they have airplanes that can actually fit and if they do, then we quote with them. If not, we don't quote with them. And that's, and that's where domain knowledge, domain expertise comes in play, because if you just try to do dumb coding, you're going to end up with a code very quickly, but you're going to lose a lot of money, because the airlines that gives you the quote, the cheapest airline, very often does not have flights between like large flights between those. They're giving cheap quotes because they have very small door size on the small planes, and nobody uses them, so they just lower the price just in case they can get something. But if the customer come back and book with you, you'll try to book with the airline, you find out that, oh shit, I can't. You go to the next airline, and the next airline is twice more expensive. Now you lost all your pence, so you're out of business. So yeah.
Right. So what are the error modes for your agent? Like if the agent does something wrong, what happens? What's it doing wrong?
So it's interesting. So we found out that it doesn't do many mistakes. Like, it doesn't do mistakes. It just cannot do stuff. So like we very quickly, we started, because I came from ML background, etc. We started with this preconcept that we need to build a test data set and validate it and make sure it's accurate, it extracts the data. And then very quickly we find out that after like last August, whenever the major, not this August, but 2024 August, most of frontier models became pretty much perfect at extracting data. Like as long as you correctly, build your prompts and you do some other tricks, once you figure out the recipe, there's no problem with it. Doesn't make errors. It just does not make errors. What you find very quickly is that any business process has an infinite number of corner cases, and like the way the humans deal with corner cases, we have this kind of a model of the world in our head. We know why some things are done because of laws of like what I described you with the airplane, with the door sizes, etc. So we can think from the first principle. If we experience some corner case, given all this knowledge we have about the world and all the constraints, we can run different scenarios in our head and find a solution out of the corner case. Machine LLMs are not capable of that. They there are some toy scenarios where they do, but in business scenario where you need high reliability, high repeatability, they're not capable of thinking from the first principle. You cannot just give them the description of the world and all the rules and the problem and ask it to solve. It's just not going to do it. It will guess some of the solution because it saw some stuff on the internet about your particular problem, but if your particular problem is not described on the internet, it's not going to solve it. It has no ability to think from first principles. So when you build AI agents, you need to be able to detect all the corner cases and either have recipes for them or have an ability to tell LLM to tell you that it's one of those corner cases, and then tell the customer we're not supporting it, or just ignore the email and don't do anything. So the big problem,
Yeah,
yeah,
I would think that because your industry is not well known, that there's not much content out there in the data that was used to train these large language models, and so they would struggle in particular with your problem because they've never seen anything like it
they
before.
they struggle horribly. It's genius child that has the IQ of Einstein, but have absolutely no concept of how the world works. And before you give it any task, you need to explain how this particular part of the world works. Yeah, it's a lot of work goes into that. So, and it shows the limitation of these models.
On the contrary, if you ask a large language model about a Kaggle data set like Titanic, it could tell
yeah,
you. It could probably tell you, everything because so much stuff has been dumped out on the internet. And that's
yeah,
one of the interesting things about like demos of these large language models is they ask them questions about something that is so written so much about online
yep.
that it couldn't possibly get it wrong if it tried. But you've got this kind of weird corner case industry where you're trying to do this stuff.
Yeah, and it's not weird corner case industry. Every industry is like that. So every industry has a million corner cases that are not written in the internet. It's the problem is people don't understand it because it's armchair professionals. Everybody's armchair professionals. But even if you go to McDonald's and spend there a day, you'll discover that there are 1,000 things that people in McDonald's do that's absolutely non-obvious to you, and learn from experience and nuances and optimization, and which are not described anywhere in the world on any blog post or Reddit post or etc. There's nothing there. And it's true anything, car wash, anything. And then when you go to more complex industry like healthcare and manufacturing, etc., the amount of hidden information that nobody knows, nobody understands outside of industry is enormous. Yeah. So I don't think that AI agent that purely trained on internet are capable of working in any business environment. Period. I cannot think of single business where the internet will have enough information for AI agent to operate.
Hmm. How autonomous is your agent? Do you just set it and forget it, or do you got to constantly look at everything it does?
I mean, we will constantly look at everything it does, but because we're paranoid, then it's going to screw it up. But from a customer perspective, it's fully autonomous. It just goes. All they see emails come in, the AI agent replying, and then if needed, AI agent will loop in the human and say, "Hey, this is it. I ran into one of these corner cases. Please help your customer." We are not going to continue.
So somebody in Indonesia says, "Look, I need to ship a pallet of baby bottles to Sacramento."
Yep.
Then they go to your website and they type that
No,
into
they
the
just
agent, and the agent says,
they don't go to the website. They email to their freight forwarder, who's our customer, And instead of human answering, they get a reply from automated assistant. They say, hey, I'm an automated assistant. I understood your quote. Here's the quote. Then that's it. And then they say, great, book it. And then it says, sure, booked it with airline. You can drop it at this location. Here's the invoice. And then the freight forwarder here in the US wakes up and they already got money. They already made money out of it. It's already made money for them.
Wow. That's remarkable. That is super remarkable. What percentage of quotes requests that a freight forwarder gets would your product handle?
It depends on a freight forwarder, but like I would say average is 80% of air freight quotes we can handle. Yeah.
Wow. That's remarkable.
Yeah, it depends. There are some that's a much higher percentage. It's almost 100 because
Mhm.
air freight. There are crazy stuff people ship on air freight. Like radiative materials, food, dead bodies, etc. So and all of that comes with restriction, legal requirements, etc. And those are corner cases that we decided not to go after because they're a small percentage, and that long tail adds up. But we slowly crawling into it, and we crawl and filling up, and that's our moat. Because whoever comes next needs to implement all these corner cases, business handle all these business rules and legalities and etc. to even start to compete with us.
So your main job now is to get that 80 up to 85 or 90, or is it to improve the quotes, or where's the horizon, like the frontier?
So the horizon, the biggest horizon is get more services support, to get it to 90, and for some to get from 50 to 80, because some customers specialize in very niche products. So for them, what is 5% for everybody else is 40% for them. So that's a big part of it. Another part that we discovered while doing this is that there are additional services that freight forwarder, not additional services, how to rephrase it without explaining again a bunch of air freight specific stuff. Because it's all was made by humans before, the freight forwarder would limit their scope of what they're doing. And they will say, I'm stopping here. That's it. I'm not dealing with this. I'm not dealing with that, etc. But now because the machine can handle it, the scope is growing. So the scope of additional services that they can provide, because it's not just air freight, it's also customs, clearance. It's also dealing with embargo lists. It's also, a bunch of other things that freight forwarders usually didn't deal. They I'm going to outsource it to someone else. I'm going to do this, these guys going to do that. But now because we're building this agent that can do 100 things in sequence without human being involved in a couple of minutes, then why not add more services and provide a more packaged solution to their customers? So the big part of it is it causes the consolidation of services and allowing them orchestrate more stuff. Yeah.
Yeah. Can you talk a bit about how your agent, what the workflow for the agent looks like nuts and bolts inside the thing? What is it? I don't know secret sauce, obviously, but I'd
Yeah.
love to know kind of how
Yeah.
everything fits together there, because everybody's building them these days, and I'm sure folks would be
Yeah, I'm not
fascinated
gonna
by it.
go into too many nuts and bolts because agent, a lot of stuff with agent is trial and error. Literally, it's not science. It's not even engineering. It's craft. You take different hammers, different nails, and you try and unlock. Oh shoot, this nail with this hammer works the best. And then, and that's where 90% of time is spent is trying in different nails with different hammers. And recipes that you will end up at the end that works are much simpler, I can tell you, than 99% of stuff that you'll find on internet. These days, if I see someone saying I'm using agentic framework, I know they're not in production. That's just an indication to if somebody says I use agentic framework, blah, pick your favorite one, I'm pretty much can bet money it's not in production, because I know the agentic frameworks are way too complex and inflexible for what actually
Can you give an
works in the
example
field.
of that?
What is the favorite one? The graph. Give me a second, agentic. I recently played with that LangGraph, stuff like that. So And then they have another one, LangChain, LangGraph, the two open source projects, very
Hmm.
intertwined together. Uh,
Hmm.
uh, that one, like if I hear someone saying that's what they use it, I know for the fact they're not using it in production. Like it just, and the reason for that is it's way too bloated and too complex, because what happened is people were figuring out all these nails and hammers, and they just keep adding them to the framework. Remember the early days of machine learning? Like you would have these machine learning frameworks with million methods, but in production you knew only 3 worked, and everything else was bloat. And that's literally what happens with these frameworks. People try different things, and it's open source products, so they just pile them in there. But at the end, you use them 3. But all that tech debt that they put in makes these frameworks very hard to use. You need to learn special terminology, special language. And they all very buggy and raw, because it's just it's optimized for time of to production, not for quality and uptime. So you pretty much better off writing most of the stuff from scratch, just taking the raw LLM API and orchestrating it on your own, like in production. That's because the number of changes that you end up doing to it, like how you're going to re-architect, how you're going to update, is going to be ridiculous. You're going to be rewriting the whole thing every week. And if you're constrained by a framework, you're just going to be struggling. You're just going to be learning how to take your new idea and how to torture some pre-existing structure into doing it. So
Hmm.
yeah, that's where we are.
Presumably that will change at some point.
It will. But the problem right now, the LLMs themselves are not very stable. So meaning the every 3-6 months, these frontier labs release new functionality that completely or partially change how you interact with machine learning models. And you end up like, my third example, RAGs, right? Before, everybody was running around with their own RAG frameworks and RAG tools and RAG libraries, and now every LLM has its own built-in RAG. And if you were using the tool that that's an example of a bloat of the tools. If you were using a tool that had its own RAG tool ability to attach a RAG to existing LLM, all that stuff is irrelevant. All that APIs and libraries and deploy, it's all not going to be usable to you, because you can just push all the data through API to the Frontier Lab API and just use it there. So. Yeah.
So I'm going to switch gears a little bit and talk
Yep.
about the team, because we get, I see questions on LinkedIn. I see conversations happening all the time about, should I be a programmer? Should I, who are the most valuable people on your engineering team, and what makes them the key people, and why?
So only programmers can do AI agents. Like if you're not programmers, I know it sounds rough, but there is no hope for you. Like there is no chance. Maybe in couple of years when the whole thing stabilizes and the tooling will become better, etc. But if you want to create a production grade AI agent, you need to be a programmer, because it's just another piece of software where instead of using third-party libraries or writing a code, you invoke an LLM. So LLM is just another way to write code and to do particular operations that before you couldn't do manually by hand, or there was no library. So it's all coding. It's all it's you automating a business process, and you implementing it in code. So the same thing we've been doing for decades. Here we just get this very powerful tool that can take a human language, unstructured human language, and turn it into structural data, or it can take a bunch of rules and inputs and make decisions without you listing up all possible permutations. Stuff. Pretty much, those are 2 use cases in a business and it can generate answer for humans. It can generate human friendly answers, replies, questions, etc. So and then it's still software. It's still end software. So yeah, we've seen this with prompt engineers. There was
Yes.
for a year maybe everybody were running around with hair on fire looking for prompt engineers. and I challenge you to find a single job posting today. So uh,
Well, people have gotten crazy about writing prompts. I mean, when we interview our users that are using Zorv's agent, people will spend an hour writing like a 2 or 3 page prompt to feed to our agent, and somebody else will write 2 sentences and get the same results, same output. So I think a lot has been made over like what's the right prompt and how to use it. What do you guys think about that?
yeah. So there are people who have great intuition about writing prompts, but there is actually logic behind it. There is a lot of logic behind it. And again, that's somebody who has engineering background. It's much easier for them reason about that logic than for someone who doesn't. Um, and I would say it's less about the prompts and more about the information that you attach in prompts to, because it's a system prompt, it's an instruction, but usually you give some user data and in the prompt, and what type of user data you give and what problem you're trying to solve has more to do with the prompt, and specifically how many concepts you're trying to use at once, how many things LLM has to keep in mind at once to do your work, how much information it needs to keep in mind, because LLMs, like my opinion, the biggest problem right now is their memory, their like RAM of things. They have this bottleneck there through which all your information comes in. So everything gets into the LLM and a neural network, and it gets squeezed into the bottleneck. And if the useful information that you need on the other end cannot squeeze through this bottleneck, there's no prompt in the world that can help you.
Then you get
You need to be,
hallucinations and
you get either hallucination, not so much lately. You just lose information. You just forget stuff, and gives you just very generic answer and forgets all the details. So. And that's so writing long prompts, and long prompts just make it worse, because when you write a long prompts, you give it more information that might be not relevant, and it's not guaranteed that it's going to understand that it's not relevant, and it's not going to sacrifice the useful information for just understanding your prompt. And that's what my guess in those cases where one sentence prompt work better than a page is because there's such an information loss caused by this slop that you added on top. So
now the context window is pretty big for these models, though, right?
Yeah, so context window is a misnomer. It's a marketing term. It's
okay.
Context window is just a RAG. That's all it is. It's they just moved RAG into the context window. Yeah, when you load like 1 million tokens in the context window, it's not using 1 million tokens for reasoning or for processing. It distills it in a much smaller bottleneck. And then process it. So and it does two things with that. It either generalizes all your million lines of million tokens, or it picks pieces and uses the pieces. So, and if your problem fits into that use case where it's useful to just generalize, or it's useful to pick a small subset, it works. But if you actually need to think through all of that, good luck. So, and Frontier Labs doing advantages there, but by just doing this, what they call it, inference time thinking, so where they run AI agent behind the scene. Literally what they do, they build this generic AI agent that detects different types of problems in different contexts, and it takes and it splits it into smaller pieces and just piecemeal through them. And they're getting better because I guess there is finite number of types of problems that people deal. So eventually it's going to get better. But you need to be aware of it. And when you code it against it, you need to know what's happening. And when you see a failure, you need to be able to infer why that failure happens, so you can backtrace and try to feed it in a better way that can produce a better result. And that's where the engineering brain comes to mind. If you don't have an engineering experience, it's very hard to think that way. It's very hard to reason that way, and you might can train per person to do that, but somebody who has the engineering architecture experience, it's just a natural way to think. It just that way and reason that way. So, because you debug it. You literally debug it and go back and do it again and go back and do it again.
Right. Uh, have you run into any fine tuning tasks? Like, a lot of people talk about fine tuning these large language models. I've never actually seen anybody doing that in order to get better results.
So
Do you guys
I
play in
mean,
that space? Or are you using kind of closed source models? Or
yeah, I'm using so. Fine tuning is the same. It's the same as the machine learning. And the biggest problem here: collect the good training data set for fine tuning. Like you need a good representative training data set, and it's trade off. So it's a chicken and egg. You need to first run enough of use cases through your system to collect a big enough training data set so you can fine tune. So, and by the time you do that, you achieve such a high quality with prompt engineering and with sequencing the code by yourself that the value that the fine tune can gives you diminishes, and that's my guess why a lot of people don't do fine tuning, because they can just they manually train it. Remember, like in machine learning, if you run enough training cycles and you don't keep the holdout data set secret, you were overfit it, and it will work. So the same here, you can overfit an LLM by just doing prompt engineering. you know, uh,
wow, man, that's
yeah,
great.
yeah, yeah,
Well, this has been really fun and super interesting. I love learning about this whole kind of
yeah.
behind the scenes world of shipping and stuff. I guess I don't do a lot of freight shipping or anything like that, obviously,
Yeah,
but
unless you
the
have a
fact that it's going
business.
on
Yeah,
in every on every flight that I've ever been on, we're also shipping stuff, and there's like a whole industry and hundreds of businesses that are about orchestrating
thousands,
that whole thing. Thousands.
thousands.
That's wild.
Yeah.
All right, well,
Yeah.
let's wrap it up with some kind of a fun little rapid fire. I've got 3 or 4 questions to ask. What is the worst bug you've ever been called into a meeting to solve at 2 o'clock in the morning?
When I worked back in my telco time, we had this term GOPB, get on a plane B, and you get emails, subject line GOPB, and I got email GOPB London. Uh, I literally packed and went to London because of my bug. So I landed in London airport, got a call that they already fixed it and I already have tickets to go back, and turned around, sat on a plane, and went back to New Jersey. So I officially been to UK, but I never walked out of the airport, and it was before internet on the flight. So all the way there, all I could think of is like what caused the bug. I debugged it in my head, and I debugged it correctly, but I was ridiculously stressed. So that was the worst bug. That uh, that taught me to write a lot of unit and integration tests.
Huh. You could have at least gotten a meat pie or something.
It was literally, I got off the plane, I opened my phone, connected to the roaming, and I got text message, fix, and your return flight is like hour 20 minutes. So like,
Wow. All right. Well, that's cool.
yeah,
I guess you
yeah,
rack up some frequent flyer mileage that way. All right.
yeah. That's
What is one machine learning or engineering myth that you wish people would stop propagating?
machine learning or software engineering myth yeah. My pet peeve is microservices. Don't do
Say more
microservices.
about that.
Just don't do it. Just don't do it. The microservices. If unless somebody truly screams at you that you need to do it and shows the valid business reasons for that. Yeah.
All
It's
right.
one of the things that's
Awesome.
super useful in the right context, but a lot of people just use it because they read that it's super cool and they want to use something cool, and they end up shooting themselves in the foot and wrecking their engineering team and their business with unnecessary cost.
Huh. All right. Last question. What is your go-to decompression activity? Hobby, sport,
Watching
show?
now watching dumb 90s movies and shows like Terminator and I like Big Bang Theory and stuff like that,
Yeah, Big Bang Theory. It's a great show.
Yeah. Or reading
Awesome.
reading crazy stuff about how chips work, or how, what's new about cancer
Yeah,
treatment,
you're
or
always learning something.
yeah, something, or what is the latest SpaceX rocket going somewhere doing something. Yes.
Hmm, awesome. Well, Dennis, hey, thanks for sitting with me for the hour and chatting. This was a really good time, and I
Yeah.
learned a lot.
Yeah. Good luck with your new podcast career.
Oh, yeah. Yeah, yeah, yeah. Always marketing.